today we're going to talk about percent yields. Percent yield in chemistry, yield means that we are producing something. Now, percent yield compares how much you actually produce in like a real world setting, where you have machinery, you have employees, and technicians, and you have different air pressures, different temperatures, all of that in a real world setting, compared to how much you could possibly make in a perfect world. And that perfect world is described by math that takes none of those other factors into account. So it's called percent yield, and it's just like other percentages. It's part of our whole times 100. Here, our percent yield is equal to our actual yield, how much we actually made, divided by theoretical yield, which is how much the stoichiometry tells us we could make. And then all of that times 100. Now I generally like to write here theoretical yield. It's from math. Is your theoretical yield. And remember that the goal of this entire chapter is on stoichiometry. You're always going to have to find your theoretical yield, no matter what, because that's kind of what I'm here to teach you, stoichiometry. All right, so actual yield is the measured amount of product determined by the experiment, is how much you would actually make of a product. And your theoretical yield is the maximum amount of product that could be made in a perfect world. All right, so we have this problem. If 75 grams of carbon monoxide react to produce 68.4 grams of methanol, what is the percent yield of methanol? So it comes with a reaction, which may or may not be balanced. This one is, but you always check for one. And then we need to take our information out of the word problem and put it into our little map and assign what these guys are for. Okay, so 75 grams of CO. 75 grams. That's how much I have of this. And then it reacts to produce 68. That's not what I meant to write. 68.4 grams of the methanol. Okay, so to get our percent yield, we need actual yield over theoretical yield times 100. Okay, so this number right here, the 68.4, is an amount of methanol that we produced. So what value is this for our formula? The actual yield is how much we actually made. And it's always going to be a product, and that's how you can tell. That's why it's not CO, because it needs to be a product. Percent yield has to deal with products. All right, so that one already has a use. Now we need to get our theoretical yield. How much methanol could we make in a perfect world? It needs to be in grams because our actual yield is in grams, and we need to compare apples to apples. So that's where this number right here comes in. You start with the amount of reactant that they give you. They go ahead and tell you that this is your limiting reactant. So I'm going to start with 75 grams of carbon monoxide, and I'm going to go to methanol. Can I use mole ratio? No. How can I get it to mole so that I can use mole ratio? Molar mass. All right, the molar mass of carbon monoxide is what, 28.01 grams in 1 mole of CO. Grams cancel out. Now can I use mole ratio? Yes, so do. Moles of CO are here, so moles of CO have to go down here. And then we're going to moles of methanol. And it is 1 to 1 in this reaction because those are our coefficients, 1 and 1. Now I need to take this to grams. So I have to use molar mass. So in 1 mole there are, I think this is 32.05 grams. Everything on top multiplied together, divided by everything on the bottom multiplied together. 5 minus 32.05 divided by 28.05. 85.8 grams of methanol. This is my theoretical yield. It's always going to come from a result of a stoichiometry problem. So 85.8 grams is how much that I could have made in a perfect world. And I actually made 68.4. So let's calculate our percent yield. Here's the formula right here. So actual yield, which is 68.4 grams, divided by 85.8 grams times 100. 79.7. 79.7% yield. Now, that's not bad, but if you are in the business of making methanol, you're losing 20% of your profit. It's just going poof. Okay? So 20% of what you could possibly be making is gone. So probably what you're going to want to do is go back and make sure you don't have any leaks in your equipment. Make sure that they're functioning properly. All your filters are clean, and start there. Then you would go and interview your employees and see what they are doing in their day-to-day jobs, and make sure that is what they are supposed to be doing. Because sometimes employees will think they're doing the right thing because they make these little tweaks and it works out better for them, but it may not be best for the process as a whole. So you have to go back and check for those. So if you get like 95% yield, that's fantastic. You're probably going to get a raise. All right? That's absolutely fantastic. 90% okay. You get below here 75%, you're probably going to have somebody breathing down your neck because he wants to know where his money is. And if you can't figure it out, you might lose your job. And that's really how percent yield works. Let me see. There's another thing there. You will never, ever have over 100% yield unless you are magic or God. Okay? That's the only way. If you do this calculation and you get over 100% yield, you have done something wrong. And you should go back and fix it. Because it will not be over 100%. Okay? All right. Now, this is a very straightforward problem. There's also a backwards type of this. But we're just going to kind of think about it this way. In this particular problem, what they would do is they would give you, and I'm going to circle it in red here, carbon monoxide, and say you have 75 grams of that. They would not give you the amount of actual yield. That's actually where the question is. How much are you actually going to make? And they would give you the percent yield. Okay? So they're going to give you that amount of carbon monoxide. They're going to tell you the percent yield, and they're going to ask you for how much you would actually produce. And this is a very practical way that percent yield is used actually in industry. Once you run a process several times, you know what your percent yield is. You know what you should be getting. So if you have to fulfill an order and you know your percent yield, you back calculate to figure out how much reactant to start with. Okay, so that you can fill the order and not come up short and have to run the process again. Does that make sense? Okay, so what you would do here is you're always going to find theoretical yield, always. And you're going to go to the amount of the product. So it's going to look just like this one, and you're going to do your theoretical yield, so it will be a stoichiometry problem. So this number you will be able to figure out. Now, this is how much you would produce, this 85.8 grams of methanol, is how much you would produce in a perfect world with 100% yield. But you're not going to get 100% yield. You're only going to get 79.7% of that. So what do you have to do to this number to get your actual yield? Okay, yes, take 79.7% of that number. So it would be 85.8 grams times 0.797. That's 79.7% expressed as a decimal. And if you do that, what do you get? Okay, 68.38, which rounds up to 68.4 grams is how much you would actually make. All right, so that's another way this problem can be switched around on you. Does that make sense? Okay, good. Now we'll practice.